We are finally ready to finish off lesson 10.3 with our last lesson. And in this lesson, we're going to be looking at how to solve quadratic equations that have a square root in them already. So they're actually really easy to deal with. When you see a square root, you're going to want to do the inverse operation. The inverse of a square root is squaring it. So we're going to square both sides. Now, this is something you're not going to run into on your homework, but I'm going to say it anyway. If you are ever in a situation where you have a thing that's a square root like this, but there's more stuff over here that's not in the square root, you want to isolate the square root part, just like if you were trying to solve for something inside the square root and you would want to move everything else to the other side. But that's not a problem here because the square root part is on its own over here. So we have x squared over here, and we have, when you square something in the square root, since it's inverse operations, the stuff that's on the inside just pops out. So we have x squared equals 5x plus 14. Now we want to move everything to the same side of the equation, which means we want to move the 5x plus 14 over here with the x squared. We don't want to go the other way because if we do, the x squared would be negative, and we would prefer for that not to be the case. We're going to subtract 5x, we're going to subtract 14, and we're going to do that from both sides. So we get x squared minus 5x minus 14 equals 0. Now we're ready to split our trinomial into our two binomials through factoring. So since there is a 1 in front of this x squared, or since this x squared is plain looking, we can do our normal way we called the magic number way. We want to multiply to, oh my goodness, negative 14, and we want to add to negative 5. So multiply to negative 14, all we have is 14 and 1 and 7 and 2. So it looks like we're going to pick 7 and 2. And since we want to add to a negative 5, we want the 7 to be negative. So we have a minus 7, we have a positive 2, put in the x's, put in our parentheses, and we've got ourselves a problem that we can use the zero product property on. X minus 7 equals 0. That means that x is positive 7, and x plus 2 equals 0. That means x equals negative 2. So these are our two numbers that we're going to test in our original equation. So we're going to see if 7 squared equals the square root of 5 times 7 plus 14, or actually we won't need to square it. We'll just see if 7 equals this side, and we'll see if negative 2 equals that side. So let's try both of those. Let's start with negative 7. Negative 7, oh, it's a positive 7. Positive 7 equals the square root of 5 times 7 plus 14. 5 times 7 is 35 plus 14. That's going to be 49. Is the square root of 49 7? The answer is yes. Now we're going to try it for negative 2. That's going to be tricky. Let's see. Negative 2 equals the square root of 5 times negative 2 plus 14. I think you can see where we're going to get, or where we're going to go with this. Negative 10 plus 14. Negative 2 equals the square root of 4. Negative 2 equals positive 2. That is not correct. That is wrong. So because of this, the only answer that we get to keep is right here. X equals 7. X equals negative 2. Even though it worked with this equation, or it worked when we were solving it, it's not going to be the solution. And the reason is it doesn't fit when we put it in the original equation. So it's very important when you're doing problems like this to test your numbers in the original equation when you're done to see which ones are correct, and if you have ones that are not.